pleasure for me today to introduce Satoshi Sekine. He's a professor at the New York University. He's been doing quite a bit of work in information extraction. He's been actively present on the main scene of big conferences in natural language processing, including ACL. I, in particular, I am a fan of at least some of his work that he's done in information extraction in the recent years. And I'm happy that you get to see live a bit of the work that he's been
done. Okay. Okay, thank you, Marius. I'm very happy to be here, and I don't know how so many people know my work, but I have been working on knowledge discovery, and recently I published several papers about that. But these different kinds of work has one particular topic, one particular objective, which is on-demand information extraction. So I'm going to talk about on-demand information extraction in general. And this is not technical talk of individual technique, but it's overview of what I'm trying to solve under the name of on-demand information extraction. Okay? So it's going to be 1 hour. And please ask me questions if you have during the talk. Okay, so this is me. This is me. This is homepage. But this year I was busy organizing conferences like texture interment and paraphrase conference, and chair for the editor for the named entity and people web search. So this is the area I'm working on. And this is the topics I have been working these days. So main topic is on-demand information extraction, and I'm going to talk about IE pattern discovery, paraphrase discovery, relation discovery, and this global thing. And also, I have been working on summarization, IR, and QA, and several basic technologies like English analyzer, named entities, query log. This is work I have done at Microsoft, and web people search and Japanese stuff. Okay, I'm not going to talk everything. I just focus on the information extraction. Okay. What is information extraction? Maybe many of you may know that is a technology to automatically extract information on specific scenario from unstructured text, like newspaper, to make a structured information like this. For example, from newspaper, given the topic is management succession, then we have to make this kind of table. This is interesting task because this is kind of understanding text, which is our ultimate goal of NLP. So we have been working on this topic. But there is a problem. Okay? Preparation for knowledge for given scenario is very expensive. So for example, we have to find out the pattern, like company announced person's promotion to position. This is a pattern to understand the event of promotion. But preparing this kind of pattern is very expensive. If you ask people to do this, maybe it takes one month to do this. And we cannot do this for every different tasks. Okay, and some people have been doing the supervised learning to create this kind of pattern. But annotating data is also expensive. So there is a restriction on information extraction in general. Preparation time, for example, in Mac, this is a contest, evaluation contest, allow us to do this for 1 month. So that's bad. And because of this, the information extraction is limited for specific scenario or domain. So that is problem. Okay, and I'm trying to solve this problem. So my goal is try to make this 1 month of preparation time to 1 minute. Okay, just 1 minute. So in other words, it's information extraction on the fly. So how can I do this? There's 2 technologies. One is use unsupervised learning method. And this is going to be applied on pattern discovery and paraphrase discovery. Also, another idea is prepare as much knowledge or tools as possible for as many scenarios as possible. Okay, this is done for the area of named entity and semantic knowledge or relations. Okay, so this is a system overflow. So how I'm going to solve my ODIE works. So on-demand information extraction receive the request from the user by the description of task. Like I'm interested in bra. I'm interested in management succession. I'm interested in outbreak of disease. I'm interested in explosion of bombs, etc. You can ask anything, just like information retrieval. And this box is inside the system. The first information retrieval system works and extracts related relevant documents. Then from the relevant document, patterns are discovered. And the system is going to find 1,000 patterns, which is not related, no structure in it. So we have to find out this pattern and this pattern are talking about the same thing. We have to understand the semantic of the pattern. That is paraphrase discovery. It automatically finds the paraphrase. Then we have a set of patterns, and we can apply the set of pattern to the document, and table will be constructed. So in order to do so, we have a language analyzer, just like part of the speech tagger, syntactic analysis, and so on, and extended named entity that I'm going to talk about, and coreference. So all of this works as a unit to do the on-demand information extraction. And these three components are very important, so I'm going to talk a little bit for each, and then I'm going to show you the demo if the internet is available, right? Okay, automatic discovery of IE patterns. So this is the real bottleneck, and this was done by my student, Sudo. So we have to try to find the company announced person's promotion to position. This is important pattern for this tab, for the promotion event. The key idea is that retrieve document on the given topic, then correct relatively frequent pattern in the retrieved document compared to the background document. That may be the important pattern for this task. And the problem is to be solved is what is pattern format. So my student tried that predicate argument. So predicate and its subject, object, or other thing. Maybe the pattern or chain of the path tree or subtree can be a pattern. And the computation time is very important. The documents is so big. The piece or pattern, possible pattern is enormous. So computation time is very important problem to be solved in order to do it in 1 minute. But the performance itself, the near human performance was achieved. This is a result. And we have 3 different models using subtree model, chain model, predicate argument model, and okay, where's the cursor?
Description of task, is it natural language or something else?
It's a list of keywords.
Okay.
Yeah, because we are using the IR component at the beginning, so it has to be the input similar to the IR engine. Yeah, that's a limitation I'm going to talk at the end. Yeah, and I believe in this case, we use the keyword from ACE corpus. ACE has a task. ACE has a description of task, and which includes keywords. So I use their keywords. Okay. And yeah, so human performance is somewhere here, 85 precision, 70 recall, or somewhere here. So that's close to that point. Okay, and the next thing is, okay, we extract lots of patterns, 1,000 pattern in the order of the preference, but we don't know which, we don't know that, for example, this pattern and this pattern may mean the same thing. In order to solve this, we have to understand the paraphrase between the patterns, the relationship between patterns. Okay, I have 3 ideas, and this is one of them. Shinyama, who is also my student, has been working on this. And the key idea for this paraphrase discovery is that the events, big events, are usually reported in different newspaper on the same day. You know, some big guy was killed in, I don't know, in San Francisco, then another paper may talk about the same thing. But the expression may be slightly different. Okay? And these expressions are paraphrase. You know? But the point is named entity, maybe the person name, location name, date, are the same. So we can use these clues as anchors. Person name are the same, okay. So I don't know, Satoshi Sekine killed, I don't know, Marius Pascal in San Francisco yesterday. The Satoshi Sekine may be the same, Marius has to be the same, and Marius, the names are same. Okay, but the expression may be slightly different, but we can recognize these different expressions as a paraphrase. Okay. So it's looked like this. So we have a pair of newspapers and find comparable articles talking about the same events. And we tag the named entity and use coreference to identify anchors. Then find the comparable sentences. Then extract these as a paraphrase. Okay. And the evaluation, so this is not really complete evaluation, but the recall precision is something like this, 62%. And we cannot really calculate the recall, but it's about 6%, 60%, 50%. Okay. Okay, so I'm going to talk about another issue. That's relation discovery by Hasegawa. He was a visitor here, visitor to NYU 2 years ago, 3 years ago. Okay, motivation is discovering particular relationship between named entity is a motivation. So we don't have a particular relation at the beginning. We want to know all possible relations between, for example, people and people, or people and company, or whatever the named entity types. And for example, between country and presidents, there are many different kinds of relations there. Or between companies, there are merge relation, parents relation, or competing relation, etc. We don't know how many are there. So we want to find out what type of relation are there and what's the instance of the relation. Okay, this is completely unsupervised except the named entity. And the idea to do this is context-based clustering. So we try to find, okay, maybe next slide. We try to find a lot of instances of pair of named entity in the document. For example, Disney and ABC. We try to find Disney and ABC, company ABC, appear in the newspaper as much as possible. Then we extract the context between Disney and ABC. And we're going to find expression like Disney is offering to buy ABC, or Disney is interested in ABC. Disney is negotiating to acquire ABC. Disney is planned purchase of ABC, etc. Then we can find, oh, there is some relation here. But one particular pair of named entity is not enough. So we have a named entity tagger. So we can have a IBM and Lotus, or something else and something else. Lots of pair of named entities, and we can cluster them, cluster the context, cluster the pair based on the context. Then we're going to find, oh, there is a relationship which is similar to this, or there is a relationship similar to other relations, etc. So clustering will produce a set of relations. Okay, this is results using the half year of New York Times. And between people and location, we find the relationship like president, senator, prime minister, governor, secretary, Republican, and coach. And between company and company, we found the relationship like merger and acquisition and parent company relationship. And this number is evaluation results. We found 23 relationships in the cluster of president, but 17 of them are correct. And senator relation 19 out of 21 are correct, etc. So we just find this. And because I have 200 category named entity, there are 14,000 possible pair of named entities, and for each of them, we can find a relation. Actually, there are not so many. Only particular pair, we can find several relations. But that's how it works. Okay?
So again, for those two numbers next to president, 17 and 23, those are the number of distinct contexts, right, that support that relation. So
Number of pair of two named entities, yeah.
I'm sorry.
These are number of two particular instances of named entity pairs.
Oh, okay, I see. Okay, I see. So those would have to be correct or not?
Yeah.
I see.
Bush and
the other question is about how many related. This must be just a sample, right? I guess of the output. How
from
many relations were there?
yeah, there are several more relations, yes, but it's not that much. Maybe we have a lot of threshold. So up to the instance has to be more than 5, then this is a result. Yeah, if the threshold go down, and also we have to have a threshold here too. It has to have enough evidence. So there must be at least 30 times appear in the newspaper in order to have a nice context. And this experiment only used the half year of New York Times. So his experiment ends here. This is it.
Are these relations one way or two way, or does it matter?
Good question. It's one way. So we care about the opposite direction as well. Right? So each expression listed, okay, this is IBM, this is Lotus, not the other way. Thank you. Okay, so evaluation results. So our cluster level is 100%. That means, okay, that top, for example, top cluster has lots of present relations. So that's cluster is correct. And okay, I have to say this is the words in the context. Maybe in the top cluster, present appears in the 100% of the instance pairs. And second one, senator, appears 100 times in the second cluster. So we name it based on the top keywords, and cluster level is 100%. And in the pair level, it's 89% accuracy. Recall, it's not easy to calculate, but people look at all the retrieved document, retrieved pair of named entities, then it's 58%. Okay, and the error maybe come from something like this. Chechnya war may exhaust President Boris Yeltsin. And between the location Chechnya and Boris Yeltsin, there's an expression like president. So the system thinks that Boris Yeltsin is a president of Chechnya, but it is not. And we have missed here like Boris Yeltsin on the end of fighting in Chechnya. But we cannot exact this because there is not so significant context word in this expression. Fighting didn't appear so much, so we cannot exact this relation. Maybe we can expand our corpus or something, maybe it helps, but based on half year of New York Times, it didn't work that much. Okay, and once we achieve this goal, we can extract paraphrase from that result. Because we have a lots of examples like this. These are actually paraphrases. But when I look at the data, it includes a lot of noise. Of course, between IBM and Lotus, anything can happen. So we want to extract only the expressions which talking about these things. So we have two filters used in more than one pair of instances. It's simple two filters. It's just a little bit simple. The expression has to be used in more than one pair of instances, not only IBM and Lotus, but it has to be used in other pair of named entities. And expression has to contain frequent term. It's not just and. It has to have some meaningful word. Then we found like A bought B, A has agreed to buy B, A which is buying B, A's proposed acquisition of B. These are found as a paraphrase. So that's very nice. Okay. And there's another idea, but I'll skip. You can read my paper. Okay. And then I move to the topic of named entity. So named entity usually has 7 or 8 categories, like location, organization, and location, organization, person, etc. But that's not enough. If we have a topic of, I don't know, disease outbreak, we have to have a name of disease, name of medicine, etc. So I try to make up the list of named entities which may be interesting for the IE task. And this ends up with 200 categories like this. And this is all manual work. So me and my student just look at the newspaper, look at all possible question answering questions in question answering systems, or IE task, etc. And this is the result. And it's still improving. Okay, I have a definition 150 pages, and I have a tagger, which is 70% accuracy, which is not good. But for example, product name is very, very hard to identify. So that's a result at the moment. Okay, and also I'm extending this work to finding attribute. So when I look at each instance of these entities, like food or train or, I don't know, airport, etc., we found that there are specific attributes for each entity types. Then we are making attribute for each as much as possible. It's not for all of them. I cannot make all of them, but as much as possible. For example, for person, there's an attribute like vocation, nationality, career, masterpiece, graduate from university and hometown, etc. And this was done by reading encyclopedia. I let people read 50 examples for each category and ask them to extract possible attribute as much as possible. Then, actually, this is the number. So I believe for person, there were 46 examples in the person category. And 46 of them has vocation attribute. And 29 of them has a nationality attribute. And 26 of them has career, etc. So this is the order of importance or frequency. And I believe this is very good resource for the future. Okay.
So when those people look in the encyclopedia to manually pick these attributes, what they call the attributes, did they preserve the label that they found in the encyclopedia?
Label of the
lexical label. Was vocation appearing in the encyclopedia as it is?
No, it's not appearing in the encyclopedia usually say that Satoshi Sekine, the professor at New York University. So there is no label like vocation or nationality. This is
how was the conversion done between something that was found to be to be representing an attribute in the encyclopedia, and then the actual lexical label that was before that is vocation.
Okay. So we asked the people, those students, to label them by their instinct, by their intuition, and then we get together and talk about, okay, let's name this as vocation.
Okay.
So there are this, yes, people name it differently.
So
but
there was quite a bit of discussion. Yeah, I was just curious how much agreement there was, but I see. So there was quite a bit of discussion, I guess. Okay.
Yeah.
Some people decide and there's profession, others vocation, and so on, and they decide, okay, all of these go together into something that we call vocation.
Yes,
Okay.
exactly. Yeah, we actually did internal data agreement of the label and what kind of attribute. But I actually haven't published this yet. So you may find this maybe next year somewhere. Okay. But this is interesting thing, and I'm working on this. So it works like this. Okay, we get the description of task, and IR system works and get the documents, and pattern was discovered, and paraphrase connect the patterns, and table will be constructed. Okay, let's see. So I present, oops. Okay. Maybe it's not connected yet. I can use this. I know. I presented this demo at ACL this year, and I was scared. People may ask some very strange questions. But actually, yeah, they did. And actually, okay, rust. And actually, it worked for some of them, at least. I know there are people who understand the context, understand the technique, and they give me very difficult questions. But and that time it didn't work. But many of the times, maybe 70% of the time it worked. So okay, so you can type in any keyword, and I know this works. So this is a kind of keywords: acquire, acquisition, merge, merger, buy, purchase. This is the limitation of IR system. IR system needs some keyword which appear in the document, just like Google maybe. So this is a keyword. I want to change this, but I don't know how. This is work by IR people, not maybe me. But okay, you can type in acquire, acquisition, merge, merger, buy, purchase, and it will take 1 minute. So we have to bear a minute. And actually, this is a task, the topic in ACE evaluation. ACE has 25 or 30 different type of events, and they include the keywords like that. And I just list up the keywords as an input.
The delay that's there, is that mostly because you're dynamically going out and fetching documents?
No.
Or is this on a stored corpus?
It's stored corpus. It's already calculated index as much as possible, but still it exact 1,000. I think 1,000 documents, and try to find the patterns which is most likely for this topic and etc. So calculation is there, but I don't really look at the documents. It's all indexed, documents, pattern, and etc. Okay, so based on acquisition, acquire, merge, merger, purchase, etc., we have this kind of table. Maybe pick one of them. I don't know, Merrill Lynch in 1998 bought some group. We couldn't identify this Mercury Asset Management Group as an organization. So that's named entity mistakes for 5.23 billion. Okay. Or something like this. So this is all table. Just what we input is the keyword. Okay. And this is a list of patterns to create this table. So this includes to acquire, acquisition, etc. So this is good evidence that paraphrase works. Okay.
Just looking at the third one on top, AOL Time Warner Disk.
Okay. Yeah, now we go to document and extract. At AOL this week, the buzz held the merger with Time Warner would be in. Okay, so actually two events appear in one sentence, so I couldn't distinguish them. Yeah. Yeah, there are many problems. Like, okay, at the moment, this label at the table is named entity label, company, date, and money. So I want to change this so that we can see that this is buyer, this is buyee, etc. At the moment, I don't know how to. We are working on this, actually. And so now time for the demo. Scary part. You can say anything, and I'll try to find it. So this has to be a question for information retrieval system.
Something in the style of attack, destroy,
Attack, destroy.
and related.
Is it right?
Would the past tense help, I guess?
Sorry?
Would variations in tense help? Attack?
I think it's on there already. I believe it's okay. Another 1 minute. Yeah, at the demo at the ACL, just people typing anything and people from Australia typing Australia. What's the event about Australia? That's scary. But 1 minute later, I found that the old sports results between Australia and something, Australia and Japan, soccer 2 and 3. That table was created. So that was very exciting. I didn't expect that, but I have never tried that, but it's, oh, not yet. Okay. Attack and destroy. What is this? Okay, yeah, this is attack event. Yeah, because we don't have a role label, we cannot really see what is what, but sounds like attack event here too. 5 Israeli soldiers. Okay.
So the classes of entities that we have there are all from that hierarchy that you showed us before.
So,
right?
sorry?
Or the classes, the table columns. They are all classes from that hierarchy that you showed us, right?
Yes,
The one
yes.
that was created manually.
The-
Location and so on.
Oh, no. This is not attribute. This is named entities.
Yeah. That's what I meant.
Yeah,
Right.
200 named, one of the 200 named entities.
Right.
Yes, that's right.
And the purpose for this again is a
Oh.
piece of a newspaper.
Yeah, this is 11 years old newspaper. This is a quaint corpus. So 1998 to 2001, New York Times, Shinhan News, and APY. Okay, so it worked like this. Get it? Satisfied? I don't want more difficult question. And okay, so yeah, in case there's no internet connections, this is the table. About 1 minute, it worked. So this is my NSF project ending next year. So I have done this, so I have a 1 year of relax. No, there are many problems here, so I have to solve it. Okay, and evaluation. So there are 25 or 30 topics in A scopus, but some of them are very rare in the newspaper, like devolves or something. So major, I restricted only 20 topics in A scopus, and table and ask subjective evaluation. I asked people if the created table is judged is very useful for 2 of them. 12 are useful and 6 are not useful. I asked like this, is this table useful to search more document to satisfy your information need? Okay, this is not a solution. This is just a clue, the trigger to search your real data. So if you look at this table and you want to click this to see real document, etc. I think that's what this can be done. No, this is not solution. This is this cannot be perfect because the pattern is not enough, the paraphrase is not enough, etc. So this may be only the help for the search. That's my objective. Okay, anyway, and correctness of the table fillers, 84% of them are correct. I pick up 100 random rows, and 84 of them are correct. 4 is partially correct, and 12 incorrect. And many of them are named entity errors. So I have to work on named entities. Okay, so I took 1, 2, 3, 4, 5 topics, and it's major part of this my research. So, and I can talk several of the others, but at the moment I can get some questions. Okay, keep going on. So my student Shinyama didn't satisfy what I did, and he tried to expand the idea of on-demand information extraction, which he called preemptive information extraction. And his idea is we can even delete queries. Okay, in my demo, we have to type in queries, but he tried to delete that part as well. How to do this? Okay, this is real technical problem, technical detail, but his idea is you can cluster the document in advance. So you can get the cluster about, I don't know, succession event, get some other events, and so on. Then you can extract a table or create a table for each cluster. Then we don't have to have a query. We can make all possible table for the corpus. That's the idea. Okay. And basically, what he did is similar to what I did, except the clustering part. But the clustering is not just clustering of the document. It's cluster based on the patterns. Find a pair of the entities that have a similar relation in article. Like Katrina and New Orleans has, and Longwan and Taiwan has a similar relation that can be found from newspaper. Then we cluster these articles, and then we can get the table. Okay, that's his, I don't know, thesis in very short. Okay, that's what he did, and you can see our NACL paper for the detail. Okay, also last year I visited Microsoft Research for 1 month, and I was invited, and I gave them the condition that if I can use Querylog, I will go. Then they said yes. So I went there, and I found the Querylog contains a lot of knowledge. That's very, very valuable resource, just like Pascal and Marius did. And what I did is, because I have named entities, so I work something related to named entities. Okay, this side query logs, I don't know, 6 months, 1.5 billion query log they gave us. I don't know what this number means, but this is what I had. And I also had a named entity dictionary, which contains 245,000. like 100 greatest Britons as award name, etc. Okay, combine these two, what I can do. That's what I did. So we try to extract the name and the context. For example, academic award winner. There was a query like this. Then there is an academic award in this side. So academic award appears with plus winner context. Okay? So there are, I can create a matrix between the name of named entity and the context. Get a picture. Okay, this is a matrix. So this is the name of award. So makeup, medal honor, Oscars, Grammy, academic awards, Eagle Scout, etc. And that's the context. Plus winners, plus pictures, plus photos, plus histories. Okay, this is a matrix. It's big. It's actually I don't know 1,000 or I don't know. I don't remember 1,000 award names and I don't know millions of contexts on this side. And we have this matrix. Then what I did is, okay, for example, look at this plus picture context. This is very common for other named entity type as well. I want to find the context which is particular on this category. Okay, like I don't want to have a X picture as a award context. Okay, also this dictionary was created by my student who may be Slappy. Like makeup is one of the award name. So I want to get rid of this kind of noise. Actually, makeup is not that bad because this is one of the subcategory of academic award. So this is okay, but usually people use makeup as makeup, not award name. So I want to get rid of this thing. Okay, and why is 4 is first and 3 is later? And problem 3, the list. Once I have 1,000 names of academic name of award, but this is not enough. Maybe students are not enough, or some new award appears. So I want to find, populate more the dictionary. And this table, obviously, we can do the clustering. We can cluster the name. We can cluster the context. What I can do. Okay. So I did 4 of them, 1 month stay. And I don't have a formula, but the key idea is TF-IDF kind of thing. Okay. For example, for the context, I use a TF-IDF kind of idea. Very popular in this category, but not popular on other categories. Must be an important context for this category. That's the basic idea. And I tried mutual information, chi-square, EMI, TF-IDF, etc. But those are not working so well. So I have a new formula I created, which is not here, but you can see from my paper at www.07. And that's result like this. So category academic, I found the context like syllabus, degree in X, PhD in X, master's in X, diploma in X, X lecture notes, etc. are found as important context for this category. That would be nice. And then second one, I want to delete makeup or something else. So the idea is that the names in this category has to co-occur with the important context I just found, okay, a lot of time. For example, makeup didn't co-occur with winners at all. It co-occur with pictures, but not so much with, not at all with winners, and award 4 times. So this is less, makeup is less frequently co-occur with the important context. So this may be noise. That's the idea. And then we found that, for example, in book category, IT, porno, space, night, we, working, candy, these are found as noise. Okay. Actually, when you look at Amazon.com, etc., you will find the book name with this title, but this is not used as a book name in the query log. That's the idea. And also, I try to populate the list. This is again using the context. So if I find the names which co-occur with many of the contexts, many of the important contexts, but not in the dictionary yet, that may be the name for that category. Then I found like Golden Globes. Actually, Golden Globe Awards was in the dictionary, etc. But Golden Globes was not. Grammys, Golden Globe, Kentucky Derby, Daytime Enemy, and the American Idol is here. So that is nice. Make me happy. Okay. And I don't have a slide for the clustering, but clustering works as well. I use the EM-based co-clustering between both categories and both names. Names of the name entity and the context are clustered at the same time. That's the technology called co-clustering. And I found that the name of awards are clustered into movie awards, TV awards, Nobel awards, etc. So that works well. Okay, that's a talk about this work at the Microsoft. Okay, and last one, I believe the last one is going to be the web people search. So this is a SEMBAR task I organized. I'm not participating in this. I organized the task, which try to solve the problem of the same name, disambiguation of the names. So for example, John Smith. Look at the first 100 result of the John Smith. There are so many different John Smiths there. So the task is how you can accurately cluster them, like this. Okay. Oh, okay. So this is one of the SEMBAR tasks. SEMBAR is formerly called SenseBar. Has a call for proposal of the tasks. And there are 27 tasks were proposed and 18 tasks was conducted. And there are 100 teams, etc. And we are one of the tasks. And there were 16 participants. And okay. And this is the data. We have names from Wikipedia and some conference and web or census. And we extract about 100 pages, 100 names for each, 100 instance of pages for each names. And there are, for example, 23 different names in case of Wikipedia, people names, etc. Okay, and this is a result. It's not so interesting. The first one is Colorado University, which has a 0.79 F measure. And there are many participants here. Okay. And basically, the many systems use this kind of technology. They are just basically clustering. A cluster based on the different kinds of things, named entities or words or etc. They use part of speech, tagger, or some people use dependency analysis, etc. Okay, and this was very successful. Many people are interested in next one, so we try to organize this next event. The fall next year or maybe spring the following year. And we want to include the attribute extraction as a subtask. Like, for example, in case John Smith, you just don't just cluster John Smith in different category classes. But we want to know that this John Smith is, I don't know, sailor, or this John Smith is labor leader, and when he was born, and where he was born, etc. Now that's what we are discussing these days. What kind of attribute we may want to extract.
said attributes or values as well?
Values, yes. For each people, we have to extract the value. Maybe we will give what kind of attribute we want to extract. And we try to design what kind of attribute we are interested in. Yeah, at the moment, we found that attributes are different depending on people. Okay, artist has a masterpiece, or etc., and sailor has different kinds of attributes. So we have to find out agreeable attribute set. Okay, and I had a visitor from NHK, that's a Japanese company, and he's tried to create a graph of relation of people. So this is broadcast company, so he has a lot of data about movies or stories, etc. And he tried to create, okay, this is a person who is doing this, and this is a brother, and he married him, her, etc. So he wants to draw the picture of people relation. And this is, okay, the technology is that name identity tagger and relation extraction, so that's what we have. But this is nice interface. Okay, that's basically it. So this is my English analyzer I created called Org System. That's available on the web, etc. Okay, so I think that's good. 3 minutes to noon. So that's what we have done. Okay. Thank you.
Any last minute question?
Person relationship, are you only looking at TV or movie summaries, or are you looking at other corpus?
Well, at the moment, we are looking at only the movie summaries. Yeah. Do you have any other ideas?
Personal emails, or even social networks. And
Social network is interesting one. But we try to analyze text, not just concurrence, etc. So maybe email sounds reasonable application. Okay, thank you. Thank you.